Thank you, Troy, and thank you everybody that wants to learn more about how we're trying to select recipients and increase conception with our IVF embryos. Right. So first, I just want to start with some averages and expectations for IVF embryos, given not everyone obviously uses IVF embryos. So just some background information. So across all major IVF companies in the US, if you bring a BIF donor for a single aspiration event, so that's we're aspirating those oocytes off of her follicle, fertilizing those oocytes and producing embryos, on average, you can expect 5 to 7 freezable embryos or transferable embryos. So 5 to 7 viable embryos per OVU is kind of what you can expect for a BIF donor in the US. For average conception, this is Vytelle data, conception data, because that's not something that's normally published amongst the other companies, so I couldn't pull any of that. But from 2024, across over 27,000 transfers, on our frozen embryos, we achieved a 47% conception rate, and fresh embryos, a 54% conception rate. So this is what I would kind of consider the baseline. So this is what we're constantly trying to improve upon, and part of that is through recipient selection. So going through the IVF process, so the top part of this diagram, so the ovum pickup, fertilization, culture, and freezing. Historically, that's where an IVF company is going to spend the majority of their resources in R&D, right? Because our value, or how we generate income, is the ability to produce a quality embryo to give back to that client that we've produced from their donor. However, the value to that client is not necessarily in that embryo, right? An embryo and a straw for them really doesn't do a whole lot. It's that calf that results from that embryo, and the premium that they receive from that calf is why they spend the time, the money, the energy in an IVF program. And there's a lot of things that can happen from the time you put an embryo in a straw to have a live calf on the ground. And so in the last few years, that's where we've decided to shift some of our R&D focus to start focusing on some of these things to help our value proposition match that of our clients. That our goal is live calves on the ground. And a big piece of that is selecting the right recipients and putting those embryos into those correct recipients. So what influences a successful embryo transfer? So these are the 3 pillars that we commonly talk to clients about when things go wrong, they go right, or just in general. So first thing up there is embryo quality. So any US IVF lab that you're going to use prior to that embryo leaving is going to be assigned to embryo quality. So a grade 1 or a grade 2 embryo are going to be your highest quality embryos. Those are your transferable or freezable embryos, depending on the company that you work with. Some companies will only freeze grade 1, some do a combination of 1 and 2. And then grade 3 embryos are also a viable embryo, but those are only for fresh transfer. And so what those quality scores actually translate to is their odds of conception. So your odds of conception with a grade 1 embryo, those are your embryos most likely to make a pregnancy, followed by your grade 2, followed by your grade 3s. The next pillar that we commonly talk about is embryo transfer technician capability. When you think about that person that's actually putting those embryos in, are they an experienced technician that can get into that uterus and up that uterine horn without causing any damage to that uterus? Vitally important, right? Like if they're causing damage when they're in there trying to transfer that embryo, definitely going to see an impact on your conception rate. The other thing that transfer technician needs to be able to do and do well is identify a CL and a quality CL. And when I say CL, that means corpus luteum, and we find those, it's a structure on the ovary that means that recipient had ovulated within the window that we wanted her to ovulate in. So I'll talk more about CLs here in a little bit, but vitally important that a transfer technician can do both of those things. And then the last pillar that we talk about commonly when we talk about embryo transfer and the success of an embryo transfer is that recipient. And so I have it broken into 2 different categories. So starting with management. So the plane of nutrition that those recipients are on, handling, level of stress during handling of those recipients. Synchrony protocols. There's a lot of different synchrony protocols that are out there. Some work better than others for embryo programs, and some work better than others in particular environments. And then heat detection. If you're using a sync protocol that you have to do a visual heat detection, your ability to do that accurately is vitally important. So all of these are going to have an effect on conception. And then there's intrinsic factors to that donor herself. So her breed, her age, her genetics, and her health status are also all going to influence your ability to achieve an embryo pregnancy from her. And that last thing that I have highlighted there is repro biomarkers. And that's what we've been spending a lot of time looking at in the last several years as an indicator or a selection tool for recipients. So that's what I'll focus on for the rest of the talk here. So why vaginal biomarkers? So biomarkers are a product of gene expression. And when we look at what factors are going to influence gene expression in the vagina and in the uterus, those are factors that we know already are factors that influence conception. So again, environment, health, genetics, nutrition, inflammation. All of these things we know play a huge role in that ability for that embryo to actually implant and become a full-blown pregnancy and a calf. And so by looking at biomarkers, it allows us to look at a full complement of all of these factors in one type of screening, in one type of assay, versus having to look at each of these individually as a method of screening these recipients. So I'm going to go into a little bit more background on current utilization practices for these recipients, the economic importance of getting these recipients pregnant as quickly as you can, whether that is from an embryo or from a different method, as well as if we're going to intervene, if we're going to make a different decision with that recipient, when do we believe that that needs to happen to have the most impact for that producer from an economic standpoint? So going into the donor recipient journey. So on the top part of this diagram, so Vytelle is a no-stim company, so we don't stimulate the donors at all prior to doing an aspiration. So you just schedule your donor for an aspiration. They just show up with your cow. We aspirate the oocytes off of that donor. Those oocytes will mature for 24 hours. We fertilize those oocytes, and then approximately 7 days later, we're either going to freeze your embryos or transfer them fresh. So if you're looking at a fresh transfer, the bottom part of this diagram becomes really important. So as you're scheduling and looking at everything for your donor, you also need to be considering your recipients. So you need to have your group of recipients picked. You have that group picked out, you put them on a synchrony protocol, and you need to time their ovulation so that it corresponds to when you've aspirated those oocytes and fertilized those oocytes from those donors, so that approximately 7 days after ovulation, you're putting those embryos into that recipient. And this is the same protocol if you were to use frozen embryos. It'd just be your donors aren't coming into play at the same time, right? You have those embryos in the tank, you do that synchrony protocol, and you're going to transfer at 7 days. So right now, the primary utilization criteria as to why or whether or not a recipient's going to receive an embryo is if she has a quality CL on her ovary. That's what we look at. So all your cows are going to come to the chute, you've synchronized them. For those of you that have done an embryo program before, you've probably noticed that your vet or your technician does not put an embryo in every single one of those recipients. Usually they pick out about 20% of them and say they're not eligible to receive an embryo. And that's based on the quality of the CL that she has on her ovary. So right now, that's the primary utilization criteria that's used across the industry on whether or not we're going to put an embryo into her or not. But when we have scenarios where we have two recipients, they're under the same management, they're similar breed makeups, they're similar age, they both have beautiful CLs, we put beautiful grade 1 embryos into both of them. One gets pregnant, one does not. So we know that there's something else happening here that we visually are not, as an industry, paying attention to or haven't quite figured out as to why some recipients are working and why some are not, when all things that we can see, they both should be great candidates to accept an embryo. And so why do we care about this? What is the economic importance of this? So I'm going to just go through a recipient utilization protocol here. So this is an example using the 7 and 7 protocol that's put out by Mizzou. This is a really popular synchrony protocol that a lot of our beef producers use for their embryo programs. So day 0 is what I'm calling the day you start your sync protocol. 7 and 7 protocol takes 17 days until ovulation occurs. And since this is an embryo program, you're going to wait another 7 days until you transfer into those recipients. So now you're going to wait a minimum of 28 days to do a pregnancy check, right? So that's going to bring you to that 35-day preg check. Hopefully you have a large group of those that are pregnant, but likely you're going to have some that are not pregnant at this time point as well, right? And so now you have some decisions to make of what you're going to do with those females. So some of our clients that all they do is put in embryos, right? They're going to get put into another group, they're going to get cycled right back, and they're going to get another embryo. For producers that maybe only put in one group of embryos in the spring or one group in the fall, they're going to put them on another synchrony protocol, but they're probably going to AI, or they're going to do something different now at that second ovulation time point to try to keep their calving window small and utilize those females as best they can and manage days open. So when we were looking at this and we're like, okay, if we're gonna develop some sort of tool to screen for a recipient, where does that intervention need to occur to actually bring value to that producer? And where we strongly feel it needs to occur is prior to that ovulation in that same protocol. So not at transfer, it needs to be prior to transfer. So if we can identify and redirect those females that are unlikely to get pregnant from an embryo, and then give that producer the ability to manage them differently, whether they get AI'd, get kicked out with a bull, maybe they call them, right? That's their management decision. But there's some pretty huge economic repercussions of managing these females differently. So first, looking at days open, if we can get that female pregnant at that first ovulation time point in this timeline versus that second ovulation time point in this timeline, that's a minimum of 52 days open that they're going to save. So using $4 a day as a cost, you have over $200 per recipient that you're going to save on days open. Recip prices and cow prices right now, as everyone's aware, are at an all-time high. Recip availability is at an all-time high. If that producer needs to be managing his females in a different way to get the most value out of her, we believe that first ovulation time point is when that needs to occur. And then when we look at this from the perspective of an embryo transfer program, so across any IVF company in the US that you're going to use, by the time you have an embryo in a straw, you're going to have spent a minimum of $200 to produce that embryo. So that's what you have sitting in that straw is $200. But there's a reason why you made that embryo, right? You have your sires and your dams, and you believe that this mating is going to produce a premium calf. And you're expecting that that resulting calf is going to, whether it's your bull sale, whatever you're doing, is going to sell higher than your AI or your bull bred counterparts. So by not putting that embryo into a recipient that's unlikely to get pregnant, there's a huge economic benefit to that as well as then increasing your overall conception of your herd if there's some females that are just not going to be a good an embryo recipient candidate. So that led us to the question, like, okay, this is all great. In theory, this would be awesome if we can select recipients. Can we actually select recipients prior to embryo transfer? And so in 2023, we went on a bit of a fact-finding mission to determine if there's vaginal biomarkers that differentiate between recipients that get pregnant and do not get pregnant. So some of you, I would have to assume, are wondering, why does she keep talking about the vagina when pregnancy occurs in the uterus? Which is a very valid point. We spent a lot of time debating this point as well. Couple of reasons why we're focusing on the vagina instead of the uterus. One, from a logistics perspective. So regardless of how cool the research is or the science is, the uterus is not an easy environment to take samples from, shoot side for a producer to do. To have passed through that cervix, the odds of transferring something, bacteria, something into that uterus is going to affect her ability down the road to get pregnant is much too high, where we don't logistically want that producer having to go into the uterus when they don't need to be in the uterus. Also, there's human research that shows that the correlation between the uterine and the vaginal biomarker populations are highly correlated. So given those two factors, we're like, okay, between that, we're going to focus on the vaginal microbiome and see what not microbiome, biomarkers, and see what we see. So we focused on one metabolite class for this research. And why we picked this one metabolite class is in humans, there's a pregnancy function that's been noted for placental development and function. And then actually in some other livestock species, there's been fertility differences that have also been noted for this one metabolite class. So that's why we're focusing for this preliminary research on this one class. So what we did is right prior to transfer, so we clean off the vulva, we take a swab, it takes about 15 seconds, you seal it in a vial, and then we were flash freezing in liquid nitrogen. So we did this on around 400 recipients, both beef and dairy recipients were in this data set. So we start digging into the data. So we start to see nice separations of these groups for some of these biomarkers between pregnant and not pregnant, and significant differences in some of these, significant differences in abundance between the pregnant group and not pregnant group for some of these biomarkers. So digging into that a little bit more. So for this preliminary research, we took samples at 4 different beef herds. When we analyzed those beef herds individually, we came up with 31 biomarkers that were significantly different in abundance between our pregnant and our non-pregnant recipients. In our dairy herd, we worked with one dairy for this, but at 2 of their locations, so the locations were about 10 miles apart. And when we analyzed those locations individually, In total, we came up with 280 biomarkers that were significantly different from each other between pregnant and non-pregnant animals. So we do know that these biomarkers are affected by environment, they're affected by a lot of other things. So we assume that there was at least some level of noise in this data. And so how we helped control for some of that was starting to combine this data. So when we combine all of the dairy data together, that lowered our significant biomarkers down to 107 significant biomarkers. On the beef side, we have 12 biomarkers that were significantly different in abundance between pregnant and non-pregnant. And then when we put our beef and dairy data together, we had 2 biomarkers that were significantly different. And so 2 and 12 probably don't look at a lot, but this is just one class of biomarkers, remember, that we were looking at. So we were pretty excited about this. We're like, okay, we think this warrants further investigation, more effort to look at more biomarkers and quite a few other things. So in 2024 and 2025, what we decided to do was open up the classes of biomarkers that we're looking at. So we're now including thousands of biomarkers in our analysis that we're looking for. And we spent a lot of time on sampling logistics. So again, regardless of how cool the research is, if it's not something that can pretty easily be used, like when that cow's already in the chute getting a shot or something during a synchrony protocol, the goal is not to add more work to a producer's life. The goal is not to do some crazy thing that they're having to spend a bunch of time rehandling animals. And so a lot of work's gone into the sampling logistics as well. So we're still collecting this data. I still have pregnancy data coming in, but we're over 500 samples right now, beef and dairy again. And then really importantly, what we did differently this time. So if you remember that sync protocol that I brought up there, we firmly believe that intervention time point has to be previous to that first ovulation. Okay, we still believe that, but we took all these samples at time of transfer from that initial data set. So what we need to find out is, can we take samples at varying times during multiple different synchrony protocols, because not everyone uses the same synchrony protocol, and do those biomarker populations hold stable across that time frame. So we took samples all the way out as far as 30 days prior to transfer and across different synchrony protocols. And so some of our findings so far. So we developed a method that we can actually store these swabs at room temperature for 24 hours before processing them, where we don't have any influence of the biomarkers and what we can find on those swabs. So logistically, that was a huge win for us. That means that when those cows are in the chute, that producer takes a swab, puts them in a vial, throws them in a box, and ships them overnight to us. There's no flash freezing, there's nothing like that involved. So ease of use has gotten a lot easier. For those scenarios where maybe they're sampling over multiple days or on a weekend where the option to just send to the lab overnight doesn't exist, we developed a method where they can go in and just normal -20 freezers. So like the freezer you have in your house or your barn, they get frozen that method, they get shipped on ice packs, and we can process them like that. So logistically, that was a pretty big win for us to get that piece figured out. Another logistical thing we figured out, so in that preliminary data set, the rejection rate of those samples was about 30%, meaning we couldn't get any biomarker reads out of about 30% of the cows we sampled. And we've gotten that rejection rate down to 5%, and it's something that we're still continuously improving on. So that was also a pretty big win for us. And then, at least for me, the most exciting thing that we've seen is stability in that vaginal biomarker population across time. So again, we've only brought it out to 30 days pre-transfer so far, but we've seen in the pregnant animals versus non-pregnant animals that there are groups of biomarkers that are stable across that 30-day window prior to transfer that exist and that we now can potentially select on. And so as I said, this data is coming in. We're currently in the process of working on the prediction models for this right now. Again, across thousands of biomarkers now in multiple classes. But this is just an example of one of the models here that we just ran recently. So maximizing recall for pregnant and only using 14 of the most significant biomarkers, we were able to achieve an accuracy of over 90% of predicting pregnant versus non-pregnant animals based on these biomarkers. So commercially, what does this potentially look like? So our thoughts are clients are going to order a kit. It'll come with everything they need, swabs, vials, everything that they would need for the amount of animals that they're planning on sampling. They take those swabs right before or during that synchrony protocol. So again, when that cow is already in the chute, when she's getting a shot, when she comes in before she gets her CEDAR, something like that. They take those swabs, they overnight them to the lab. And then the big piece that we've also gotten from a logistics time point figured out is we can have those results turned around within a 1-week time frame. And when you think about that slide that I showed in the beginning again, where we talked about that synchrony protocol, why is the 1 week time frame so important? So if we talk about that 7 and 7 protocol, so right, we take a swab at day 0, so the day your first shot in that protocol, you take a swab, you overnight it to the lab. If we can have a result back to those clients in, 7 or 8 days, that still gives them 10 days to decide what they want to do with those recipients that we're saying are core candidates for an embryo. So they can decide a different breeding method, they can decide something else prior to that first ovulation time point to still try to manage days open in their female herd. So what these results will actually look like is a categorical recipient classification. So these thresholds, we're working on setting them right now based on our prediction models. But it'll be, this is your group most likely to get pregnant. This is your group least likely to get pregnant. And then you'll have your middle of the road cows in the middle there. So how do we actually foresee clients using these results? So again, my scenario that I presented in the beginning where, okay, now they have the option to AI, bull breed, do something different. That's for us, that's what we thought originally. But after talking to quite a few clients that have helped us gather data so far, or that are going to be part of our soft launch here this fall, we've heard some other feedback that has been interesting. So some of them just want to call. They're like, nope, she's not a good candidate. She's leaving our herd with the prices of recips. They feel like that's the better option for them to just get rid of her. But another thing we've heard, kind of for that same reasoning, is recip populations are quite limited right now. The recips, everybody's scrambling for recips at the moment. So there's some clients that don't want to get rid of any recipients. They need every single one, even if the odds of her getting pregnant is low, they still think it's worth it to try. So what they're planning to do is kind of hedge their bets a little bit. So their highest matings or their embryos that they're most excited about, and they think they're going to get the highest premium from, those ones they're going to put into those recipients that have the highest likelihood to get pregnant. And then some other lower value matings, then put those in those groups that are less likely to get pregnant. So like I said a minute ago, we're planning this fall to actually commercialize this with some of our larger clients. So that's part of what we're excited to see is once this is actually up and rolling in the recip programs, how are they using it? How are they making culling or breeding decisions? So that's something we're excited to see. And then as part of that as well, we obviously have our predicted differences as what we think we can expect based on models for these different groups. But actually having that true difference in conception data between these recipient groups will be really important for us to make that go-no-go decision for full-scale commercialization, hopefully in 2026. So I'm really excited about the data that's yet to come here this year. So in summary, are there vaginal biomarkers to differentiate in those recipients between the group that gets pregnant and does not? Yes, we have been able to show that there are differences in those biomarker populations. Are they stable across environments and breeds? Yes, we've also been able to show that. So on that note, those 4 different breeds from that preliminary trial were all around the country. And from the herds that we've been collecting on right now, again, all around the country, different breed makeups that went into those. And we're finding stability across all of those data sets on the markers that are being represented in the pregnant versus non-pregnant groups. So can we use these biomarkers to screen? Based on everything we've seen so far from the models, we feel quite confident that we will be able to do that. And then is it logistically feasible? So is this something that, again, it takes 15 seconds, not 5 minutes, not an extra trip to the shoot. So logistically, we also feel like this is something that should be able to be implemented by producers that are using an embryo program quite easily. So with that, thank you for everyone that came to listen a little bit about recipients and happy to answer questions.
I have 2 quick questions. One is, what do you see in those biomarkers that tell you whether they're good or bad, whatever?
Okay.
And then secondly, is there a distinct advantage in the recipients being crossbreds or composites versus straight?
Sure. So the first part is what do we see with these biomarkers? So what we're looking at is relative abundance of those biomarkers in those females. So that's the metric that we start with. And then we look, is there a particular biomarker that's more abundant in those females that get pregnant versus do not get pregnant? So that's what we're looking at from a biomarker perspective. And as far as recipients go, so the vast majority on the beef side of things, they be some type of crossbred. So typically our crossbred females are the ones that are the chosen recip for most herds, even for our purebred producers. A lot of them use crossbred recips, and that's typically what people get along with really well.
Have you had any cows that have been tested more than once? So let's say she was tested the first time and it came back that wasn't fit for every. Have you had any that have been tested again?
Yeah, so we do have cows that have been tested more than once, but we haven't actually looked at that data. So that's part of this new data that we've been collecting. There are some that it actually unintentionally, they got tested more than once. They got tested, they came up open, and then when they went to sample their next group, they tested her again. And so it's in the data, we just haven't broke that all down yet. Oh, yeah.
Can you try to combine the information with the cow and that cow though?
So most of them are crossbred cows, so none of them have genotypes that have already been done on them. As part of some of our other recipient selection programs or projects that we have going on, we have genotyped some of them, so that's another down the road potentially to be used in combination, but so far we haven't combined that data. Yeah, I mean, this will for sure be, I mean, the thought is less than a $30 test per recipient, so as far as genotyping versus, they'll be similar costs, yep.
I mean, I expect this to be more predictive.
Yeah, no, again, we've had the same question, we're attacking the recipient question from more than just the biomarker angle, and DNA is one of those, and again, this one just, because it's working, honestly quite well, we've, kind of gone full force with this one, but that is something that we will be looking at. Yeah, so again, when we started this project, metabolites was about one of 5 things that we started looking at. And this is just so far the one that's shown the most promise quickly, where we, again, just doubled down and got more data on it, but it wasn't like, this is what we feel super right in the beginning. It was, we're gonna try a lot of different things and see what starts to work or what we can find something.
Have y'all done any work with just a straight AI program also to see if there's any correlation that way on that?
We had, the clients that have partnered with us on this, that's a question that we've gone a lot. I think eventually down the road, once this gets a little bit further, that's something that we're probably willing to look at, but it's not, we haven't yet.
So was your goal to increase your conception rate or to change your percent turnout on your initial CL tab check? And then the second part is, we seem to lose a lot of the full bulls at 60 days. We seem to lose, we get a lot more opens with the resets.
Sure.
So I don't know, and we're losing embryos, putting them late, and then we don't have a rule in there to clean up. So with this, identify some of those problems.
Sure, so for let me think back to your first question. Repeat your first part of the question.
Percent, is your goal to increase?
Okay, yes.
Percent, or just identify the non-recent?
Yes. So our goal is to increase conception with our embryos. And we believe part of that is getting rid of those recips that are not a good candidate to receive an embryo. So if this recip does not have the capability to maintain a pregnancy, obviously she's hurting our overall conception rate. And so that's why we started down this journey, right? Is to identify those recips that shouldn't receive an embryo to begin with. And to your point of it being at time of CL kickout, our hope is that those recips never even make it to that point where there's a vet looking for a CL. We hope that at that first ovulation, they're being used some other direction, right? Again, up to the producer on how they want to use it. Some have said, we're still going to put an embryo on her. We're just going to put our lower value embryos in her. But our goal is to increase conception on the embryos, and we think identifying the recips properly is a part of that.
What percent are you seeing in increase? What percent pregnancy rate are you increasing?
So again, we're just in the modeling piece of that. So this fall, that's the data that we'll collect from these herds that are actually going to implement this. And so hopefully next year, or even 6 months from now, I'll have some more real data on that. And from your bull question, I mean, hard to say, right? Like, if you think that you're getting opens once you're pulling those bulls and they're from your embryos, then that would probably indicate an abortion issue and then not having a bull breed them back. But without looking at your herd specifically or what's happening there, it's, I mean, pretty hard to say just generally.
All right, you have the floor, Mr. Mayor.
But
So when you're looking at your vaginal environment, you're saying it matches your urine environment. Does a cedar have any bearing on changing the vaginal environment?
yeah. So, and just, so we have not actually done the like, we did not sample uterine environments and vaginal environments to confirm, right? But there's enough out there in the literature for humans that we felt confident that that's the way we were gonna go forward. I don't know about the cedar, so in all the protocols that use a cedar, I've asked clients to take a sample prior to cedar placement. Because I'm not, I mean, when you assume vaginitis and all the other things that come along with the cedar, we're not looking at bacteria per se, but I don't know how that's gonna change the profile, and so we're just trying to avoid the cedar thing for now.
On, the pregnancy data, were your technicians still culling those that didn't have a large enough CL?
You mean at kickout or out?
At transfer.
Yeah, so if they don't have a good CL, they wouldn't have received an embryo. So there's actually quite a few samples that were taken prior to transfer that those recipients never even got an embryo put in because they didn't have a CL. Yeah.
Yeah, and accuracy on it.
Not yet. So again, we've used some preliminary models. We're gonna switch to some machine learning models. And so we have not decided on our prediction model quite yet. So again, in 6 months, I hope to have some more really cool data for you guys, but not quite yet.